take pictures, see something you like, please tag us on Blue Sky. We have one post. We're on our way. But yeah, we'll keep working on that. So our main speaker tonight is Benjamin Garvey. He's a visualization engineer who has been doing work in open source and side projects for over a decade. He has had experience in startups and big companies like Adobe and Betterment, and is currently working in a Y Combinator-backed startup, Common Paper, which I'm sure we'll hear something about. So without further ado, please welcome Benjamin Garvey to the stage.
Thanks, Cameron. Let's join this Zoom. Get rid of all my windows here. Go to the slides. All right. All right. Thanks a lot for having me here. It's been a long time since I've been to this office. It was 6 years ago in 2019 where I came to a meetup. I looked up one of my old tweets, found this one was really cute. Turn this on. This is my first New York Data Viz meetup, and I already love Naomi B. Robbins. She was like roasting me about some Philadelphia joke, blaming everything about Philadelphia on me for the whole talk, which I really appreciated coming back to it over and over again. But it was a really good talk. But today I'm here to talk about Lineage, which is a project I've been working on for a really long time, like 10 years, more than 10 years. You can see, well, I'll talk about it later, but it's a network graph. You can see there's some important things going on there. But first I want to talk about something I did last Sunday. I took a sewing class. This is me. This is so see my fix. This is a button I sewed. That's me taking a picture of the button I sewed. And what was really kind of cool about the sewing class was like I hadn't been in a situation where I just felt like a complete noob, like at the floor. Like I knew nothing. I didn't know how to thread a needle. I didn't know how to pick up the needle. It was like on the ground. I couldn't even get it off the table. It was really tough. And it's just like I felt this like, and I'm around people who have been doing it for like, even the people that were also the new people could do 100 times more things that I could do. And I do a lot of these data viz talks, and I feel like there's a lot of people in the room who are at that level in there. So one of the things I was thinking about, like, how can I make it easier for people when you're giving a talk about something that to you seems like just a basic thing, but it's an assumption you've made that they know about. So I thought about this idea that I should start more talks with like an acknowledgement of assumptions, right? So if we have like a list of things that I say like, oh, these are the things I'm going to say. I'm going to assume you guys know something about it. And it's okay if you don't, but the talk is really geared to people who know sort of like these certain basic things. And then maybe you can go look them up later if you're not familiar with it. But it gives, if there's stuff in the talk that I'm talking about that you really have not heard of before, feel free to ask me and I can add to this list. But the things I'm talking about are, you kind of understand what data visualization is and how it's normally used, like a bar chart, line chart, pie chart, that kind of stuff. You understand that data can be stored and transformed in various ways, like text files, databases, spreadsheets, and data can kind of move around from different formats, and you might lose some data along the way, but it's kind of how it works. You're familiar with what a web browser is, and all the work shown here today runs in a web browser. And you're generally familiar with the concept that a web browser can show text and forms, but also can draw shapes, lines, circles, that kind of stuff. And then lastly, like you're familiar with the concept of open source software, that there's software that's out there that people freely give you the source code that you can clone yourself and modify it and use it in ways either for commercial or non-commercial purposes, but that's a thing that people are aware of. So that's where I start. But first, who is this guy? I'm Ben. Cameron gave me a nice introduction. I am not a data viz engineer. I haven't been one for at least 4 years, but I was one for a while at these three companies, RJ Metrics, Magento, and Adobe. You've probably heard of one of the three companies on that list, maybe heard of two. If you've heard of three, you probably worked with me before, and there's a couple of people here that have. RJ Metrics probably most famous now for the genesis of the DBT project. Various DBT came out of that from people that worked there. I worked with Betterment for a while. They helped them open an office in Philly a couple of years ago, or actually 4 years ago now. They're a New York startup that's actually been around for like a fintech company, been around for like a decade. And then I'm currently the CTO and co-founder of a startup called Common Paper. I got some other places you can find me at bengarvey.com. I have a whole set of charts called plotdevice.bengarvey.com. I'm obsessed with Twin Peaks, RIP, my man David Lynch from a few weeks ago. And then I'm also on Blue Sky, like everyone else is now. But so a quick shout out because I took a half day off to travel up here. This is my startup common paper. It has nothing to do with charts. Like our logo kind of looks like a chart, a weird chart someone made in D3, but it's not. Maybe one of the fails, but it's a open source legal tech software that the software is not open source, but our contracts are open source. So it's written by not by AI, not by ChatGPT, but it's written by real lawyers that have worked in the industry to create standard contracts so you don't have to reinvent the wheel over and over again. We have NDAs, cloud service agreements, professional services, DPAs, BAAs, all the software, all the contracts you need to sell software as a service. That's who we'd use this for. So if you're starting a startup, you have to sell to a big company, we have a contract you can use without talking to a lawyer and build it yourself, which is cool. So just a quick plug for them. If you could sign up right now on this website and send me an NDA, and anyone who sends me an NDA by the end of the talk today, I will give you a common paper sticker today. All right. But the most important thing about me for you guys is I am the co-organizer of the Philadelphia Data Visualization Meetup. You can join our group on meetup.com. And let's talk about your next day trip is March 12th. You can come down to our next meetup. This is Independence Hall. It's really close to where we have our meetups at 4th and Market. This was the capital of America before it was cool. We should probably just like change it back to like whoever team wins the Super Bowl, that's where the capital of the United States is again. Let's not tell the current administration that we moved it. It also looks like this, like a Blade Runner outtake or something too sometimes. But this is the meetup group. So definitely join up. And I'm going to set a timer so I can make sure I'm good on time here. So please join our meetup. We have 1,800, not the 8,000 like you guys have, but we usually get a good group and we meet every 2 months. It'll be March, May, July. And we usually get like 2 or 3 speakers and then we go hang out at a bar afterwards. It's a good time. Cool. This is a picture from one of our events. This is my friend, Dr. Rita Ludwig. She's talking about how she uses visualization to help clean up data sets that she uses for her work at Temple. Cool. And before we get to Lineage in particular, we're going to talk a little bit about network graphs, how to make them, what they look like. And for some of you, this will be basic, but for a lot of other people that haven't really thought about network graphs, we're going to talk about some of the lingo and the jargon that goes into it. This is a network. So this is a JSON object, JavaScript object notation. So we have a collection of nodes and we have a collection of links. So this is like we have 6 nodes here and 5 links, and we have an ID for every node, and the links define a source and a target. So we have this link, this first one goes from ID 1 to ID 2. So it's going to be a link between these 2 nodes. And as we define them this way, we can sort of draw them. It looks like this. So we have node 1 linking to node 2 with that link in between. So a node is really just an object. A node is an object. It's a thing, right? You can do crazy stuff. Oh, I went all the way back. What the heck happened? You can do crazy stuff with network diagrams, but really I look at any network diagram should really make the nodes objects, nouns, things like that you can hold in your hand that's a thing, and the links should be relationships. You know, a lot of people call them edges. I don't like to use the word edges because like a square has an edge, a circle has an edge, but a link just means a link between 2 things. You're not going to get confused about what an edge means. I like links and their relationships. It's how those 2 nodes relate to each other. It's a mother and child. It's an employer. It's a nemesis. It's whatever relationships you're defining. That's the relationship between those 2 nodes. Cool. So how do you draw a network graph in a web browser? I really like this slide. I feel like it looks like I got it from like Shutterstock or something, but it's just like my notebook that I drew in my table and put that text on it. It just like looks kind of nice. So there are 2 ways to draw a network graph in a browser: SVG and HTML canvas. Well, actually, there's 3 ways you can use WebGL, but we're not even going to talk about WebGL yet. That's like a future project for me. So let's just pretend there's only 2 ways to do it and talk about those 2 methods. So an SVG looks like this. It is just like an HTML tag, like anything else in the browser. Why does it keep doing that? Sorry for everyone watching on the Zoom. Here we go. So an SVG is a scalable vector graphic, and it just is defined just like an HTML tag. So there's an SVG tag, which defines a container for the rest of the tags. We have a bunch of lines, circles, and text. The lines have these variables inside of them. So we have like an X and a Y value for the start of the line. We have an X and a Y value for the end of the line. We have the stroke, which defines the color of the line, and the stroke width, which defines the thickness, right? Same thing with circles. We have an X and a Y and a radius. Same, the fill is always the inside color. And then the text has an X and a Y coordinates too. And then the font size and sort of the text that it shows up is actually near here in the tag itself or between the tags. And so it looks like this. So we have a 1 and a 2 and a 3, a 4 and a 5 and a 6. And it's just draws what we told it to draw. The kind of the pros and cons of the SVG is the pro is that it's human readable. Like you can look at this and sort of understand what it means pretty easily. There's no loops. There's no like hidden variables. It's kind of just pretty straightforward. The other thing is it looks good at every scale. This is what scalable vector graphics do. You could, because we're defining these with all the variables, you could look in as close as you want, zoom out as far as you want. It's always going to look perfect. And then the other one is interactivity is easy. So why is interactivity easy? It's because if you think about what the browser is doing here, it has all this stuff in the DOM. And you don't really need to know what the DOM is. It's the document object model, but it's just like all the tags that are in memory in the browser at that time. And so anything that's available to the browser or any of the other tags is also available to you as an SVG. So if you want to make something where you have a circle tag and you want to put an on-click event for JavaScript, you can just put it right on the tag and you don't have to calculate where that circle is in order to make an interactive an interaction with that tag. Whereas other types of like Canvas, you have to calculate yourself. So, and then the cons is that it's kind of slower. If you think about like a really, and I just spelled memory wrong there, but the if you think about how like if you had a really complex visualization, instead of like dealing with pixels, it's got to deal with like many of these tags. And so eventually, like SVGs are great for things like logos and they're good for app icons and things like that because they're pretty simple. But once you start getting really complex visualizations, they're even really good for like simple charts. But when you get to really complex visualizations, you're going to go with something else like Canvas. So let's talk about Canvas. This is a 3 columns of an HTML page. I try to fit on one page here on the widescreen. And we have the header tags up here. We have a canvas tag, which defines the height and width. So it's just like a little box, a little rectangle on the page. And then we have a script tag where we define the network like we did before in JavaScript. And we have 3 functions here: draw a link, draw nodes, and then draw the text, draw the links. And so you see like we have a drawing context that we get from the canvas. So we select this canvas.getContext2D. And then we have this context variable where we start the drawing of this link. We move to where the start of using the X and Y of the source. We define the end of the line, the X and Y of the target. And then stroke style is black, the line width 2, and then ctx.stroke is when we just like paint that line in the canvas like it's Microsoft Paint or something. So once that's in, like the browser sort of forgets everything it did about that. It just knows that there's these pixels on the canvas in that spot. And so you can do this really fast over a long period of time with lots of different objects. So this is how you would define it with Canvas. The pros are it's faster than SVG, especially for when you have many of these to draw, because it can sort of just forget about them as soon as it draws it. But interactivity is harder. So if I want to click on something, I have to then, okay, I have an event listener on the canvas tag, and I could say, oh, I clicked on this, but it's only going to give me the X, Y. Then I have to go back into my memory of where these nodes are and say, okay, I need to know where I clicked in order to provide some interaction for that. So you have to do a lot more work on your own to get it to work. Also, it looks really bad up close. So you can start seeing like pixelated stuff because it's if you haven't redrawn it, it just sort of looks like that. So conclusion, I think this is not the conclusion of the talk. It's just a conclusion of SVG versus Canvas. But I like SVG for a lot of things. But for network graphs, I would say if you're going to do any complicated at all, I would just jump right to Canvas. And you might say like, well, like why do we care? Why don't you just use D3? Or why don't you just use Chart.js or Plotly, or whatever? And it's because a lot of these libraries let you choose either one. You can like D3, you can do this in Canvas or SVG. And for a lot of stuff, for D3, you're going to want to use SVG. But for network graphs, I think just start using Canvas like right away, I think, if you're going to do it. Cool. So now we're talking about D3. D3 is for how many people have used D3 before? Like myself, right? So most of you knows what D3 is, like more than half the room. D3 is it's not a chart library. it seems like it's a chart library. It was created originally by Mike Bostock from the New York Times to build like all the great New York, probably in this building, the New York Times visualizations that came out around the 2010s era. And they had to be like do everything, right? They weren't publishing like a little simple USA Today chart in the New York Times. They're building these interactive experiences, right? So they were related to data, but they were tied to data, but they were not just straightforward charts. And so I think D3 is more like jQuery than it would be like chart.js, right? Stands for data-driven documents, and it's a JavaScript library for selecting, transitioning, and expressing data. And I really like that worry about expressing data because I really think about, I'm going to talk a little bit later about what I think data expression is, but it really is the best thing that I think it's out there for if you want to have every control of every single pixel that's out there. It's the tool you're going to want to use. And if you don't want to have to do all that, then it's not the tool you want to use. And it's really kind of cool. I feel like it's really not opinionated about what you're going to do. You can kind of do anything you want. And so it's almost like it's like totally neutral to what your project is, which makes me put like, if I think about like a D&D alignment chart, like Mike Bostock with D3 is like right in the middle of this chart. Anybody have any suggestions for who should be in the rest of this chart? Here are my suggestions of who the rest of the people should be in here. So we got like Hans Rosling up here on the left. Can anyone name like more than like 6 people on this chart, I think? Wait, let's get this here first.
Playfair, Tufty.
Tufty's lawful evil. Sorry. Tufty is my data hero, but he's like so fundamental, like this is the rules kind of guy. So we got Hans Rosling on the top left. So William Playfair, this is the guy who invented the line chart, the bar chart, and the pie chart. Like these were things that were invented by one person. I've posted this chart before and someone's like, there's actually no actual pictures of William Playfair anywhere. This is like his nephew that showed up on Wikipedia one time. So it's not even really him, but probably looks a little like him, I guess. We got Fox News that plays fast and loose with the axes down here. We got Trump, who's literally just drawing on the hurricane charts with a Sharpie. So he's in lawful evil. Mona Chalabi, her work's really great. She's really awesome. And Nadia Bremer, who does amazing work too. This guy, Luke, I'm trying to remember his last name. It's in my notes, but he's probably the least famous of anyone on here, but he used to be a customer of mine. His website, let's see if I can find yeah, Luke Murphy, his website is amazing, lukelab.com. Hopefully it's still available, but he has really great stuff in there. Anyway, quick diversion around that. So if we talk about, this is like the simplest like D3 force directed graph you can make. So it looks pretty similar to the canvas one we did before. We have an HTML canvas tag. We have a query selector that selects the canvas. We have a context here to get it. And once we have the context, then we can draw on that canvas. We have our network, drawn right here. And then what we have here is we keep track of the next node to assign an ID. And we have this like D3 force simulation. So what D3 force simulation does when it creates a network graph, so you don't have to like provide the layout. It will find its own layout with the simulation. So it uses basically two main ways to do that. There's like all the nodes repel each other and all the links like hold those nodes together. So you can play with the amount of force that the nodes repel each other and how strong the links are to keep them together. So you have 2 variables there for that. So one of them shows up here in this force link and one shows up in the force charge. And then we draw this graph, we clear the rectangle and let's run the simulation many times. It's sort of like as the force directed graph will sort of find an equilibrium where the nodes and the links kind of find their spot on the graph. And let's do a quick code demo here. Let's see. All right. So this is the code pretty much I have here. What we're gonna do is we're gonna run this real fast. All right, there's our force directed graph we have. Let me move this zoom window out of the way. All right, and so there it is, not doing much, but what we're going to do is we're going to add to it. We'll add an extra node. Now refresh, we have an extra node there hanging out, getting pushed away from the rest of the network. So why don't we link it up? We'll say, okay, node 5 should link to node 1. Oh yeah, you don't have to be the mic stand. I can tell. This,
Move away from the room mic because I think it creates a little feedback.
okay,
There's one share.
I can go over here. It's fine.
You
cool.
need to free your hands.
There we go. All right, so now it's linked in with the rest of them. We can see that. So with this is kind of cool, but there's not really any interactivity here. So I pre-coded up another example here. This is the click example. So what we've added in the click examples, it's pretty much the same as what we had before, but now we have an event listener that's sitting on the canvas, and we check to see in the canvas tag like where we're clicking and are there any nodes there, and if so, what this does is it creates a new node, it pushes it onto the array of nodes, and it pushes a new link in the graph, linking the node I clicked on to the new node that was just added, right? That was the only change there. And then we're going to go back to that one now. All right, so it's the same, pretty much the same one we had before, but now if I click on this guy, he pops out. And what's really cool about D3 and really what really got me excited about it in the beginning was just the idea you can sort of have this like really like visceral interaction with this. That looks like it's kind of alive, right? Can I add to one there? Yep. Keep adding them. And it's not like I click on it and just like it refreshes the whole thing or the page is just like kind of like no delay in that, which is really great for small sets like this. It's cool. So now that we have gone through all the stuff around network graphs and D3, let's talk about Lineage, why I made it. So we have the network graph. What would we need something else on top of that for? So the reason I made Lineage was because I wanted to have like something, there was a lot more features I needed, like just that clicking we were doing, but there was tons of other stuff I wanted to do. And Lineage is an open source data expression engine for network data built with genealogical data. It was the second big open source project I tried to work on. I worked on another one in like 2012. And you can see the initial commit from the project was like 11 years ago, a long time ago. The project goals were to browse a few thousand family members. I think I had 2,800 nodes at the time, make it like searchable and filterable. You can do a text search of people's names, which filters everyone out. I wanted to stand on its own as like an art project so that you could hit play and just watch it go through, and it was kind of like a beautiful experience to have. And then in Lineage 2.0, we added sort of different views besides the network view. We added a cluster view where it cluster everyone by their last name, and it would also add like a timeline view so you could see just everyone at once, all laid out sort of like from the oldest to the newest, right? So it's really, if you think about it, it's like a D3 force directed graph plus time. You've seen these like racing bar chart videos and stuff that people post. This is like a racing network graph, but it's an interactive thing you can work on. I wanted to see my family's history grow over time. I really wanted to be able to search through the data and have it update instantly. And then just some other useful, nice to have network graph stuff. So we're talking about data expression. What is data expression? I think about this idea of data visualization is not really enough. I think that there's this thing called the streetlight effect, where this old joke where a drunk guy's looking around on the ground for his keys by the streetlight, and a cop comes over and says, "What are you doing?" He's like, "I'm looking for my keys." He's like, "Did you drop them here?" And he says, "No, this is just the only place I can see." And I feel like we run a lot of companies and business intelligence on this idea that you could do it from charts, not from actually understanding the problem at hand. So it's like trying to learn how to play chess by looking at a chart of chess pieces over time instead of watching games and understanding the rules. And I feel like data expression is the way that you do that. The way you sort of get past data visualization is by having interactivity, animation, search, interact, all this stuff that you need to actually understand the game you're playing instead of just the outcomes over time, like this chess piece. And this is Kasparov getting beaten by Deep Blue, but I had to update because the slide is so old, so I put Beth Harmon from Queen's Gambit into it. So cool. So that's like, there's a couple links here to D3 stuff about understanding algorithms, one of my favorite posts of all time, but I don't have time to go through all that today. But first, I got to give a shout out to a very special lady. No, it's not Beyonce who won the Grammy this year. It is my Aunt Peggy Margaret Haley, who collected all this data. So I've been working on this thing for like 10, 11 years. She's been working on this for like 50 years. Like she's gone to Ireland like 100 times. She's collected data on her side of the family. She's even gone on to my dad's side of the family and collected data and just recorded, when people were born, when they got married, when they died, who they had kids and just really collected all this. Like I wouldn't have this project at all unless it was her, because I didn't get this data from like Ancestry or anything, or my family or anything like that. It's from her, and her Apple IIe was the first computer I ever used, which is kind of cool. So this is me and her in 2016, 2023. I'm wearing a Pac-Man suit at my cousin's 80s themed wedding in that one. But I've been giving this talk so long. I originally had a Vine embedded in the video, but I can tell you what was in this video, which was she at our family reunion, she would have like a pop-up tent, and she would put all the a bunch of 8.5, 11 sheets of paper printed out of the family tree on the inside and the outside of the tent. So this is me running around the tent, showing how big this Irish Catholic family was. So I tried to do some like traditional BI stuff on it first. This was like the year everyone was born, so from like 1930. These are all like the descendants from my grandparents. And one of the things that was kind of cool, I did this chart in like 2013 or 2012 or something. And then I was like oh, well, now it's like 2025, 2024. How good was my projection of like how many people were in the family at the time, which is that green line. And so I sort of try to figure out like where that would land. And I texted my aunt and she said, we're at like 148. So it's pretty close. So Lineage 1.0 problems. She used this software called Master Genealogist, which is like very proprietary software. It was hard to get the data out of it. We finally figured out a way to export all the data, but it was in these weird formats. And there was missing stuff, like tons of missing data, as you can imagine, you just don't have it. So a lot of the data we had to like, work with. There were weird nodes in there that I didn't understand. So the solutions there was finally getting everything into a CSV file, approximate a lot of the missing data. So we had to do techniques like, we're just going to add, we don't know how old your parent was. We're just going to add 20 years to the kid's age, and we're approximating where it's going to be. I used Ruby to create the files that I needed out of the links in the nodes at the time. And it was pretty good. And then Lineage 2.0, there were a lot of performance issues. Once you started using it, it would get really slow. Also, it was kind of boring. Like once you saw everyone, there wasn't much else to do. So the second version, we added these like clustering views where you can sort of cluster by names. So you could see which names were more popular, or how many, not really more popular, but just how many, at least in the data set. It's kind of fun to watch. And then a timeline view, we could see over time people born a long time ago versus now. So then 3.0 comes around. So 3 is more recent, like probably in just the last year or so. There were a lot of unanticipated use cases. So one of them was business that I didn't anticipate at all. Like the former boss that a few of us had started using this as his pitch deck for raising money. So this is a screenshot from a talk he gave at our DataViz meetup. The company's called Crossbeam. They do like corporate partnerships as a service, and it was like breaking this poor computer, like running all this. This is like a D3 force directed graph with just like, I don't know, 50,000 nodes in there. And what he would do is he would like show the progression of time of the company when they first started, when they had no customers or like just two customers, and grow it all the way up until it's like this hideous, disgusting, like it's actually like gross to watch. This thing spin around on a giant screen, but like it really convinced, I guess, a bunch of VCs to give him a whole bunch of money to work on this. I think he said he raised $70 million just on this pitch. But anyway, this is not really set up for this use case. And I've even tried to use it on our customers to try to like view how many customers my company has. And just not it wasn't really set up for that. Working with multiple data sets because I wanted to work on my family tree, but then also work with other stuff. Performance is always an issue. The browser zoom wasn't really good to like I was using browser zoom to like zoom out a little bit and it wasn't good enough. It was just really hard, even like for people to come to it, because it's an open source project to dive in and get started. So I really had to fix a lot of this stuff, and most of it's fixed, which is cool. So now it uses mainly configuration over code. If you use Lineage now, all the stuff that you actually want to change in the code is now configurable in a JSON file that you use outside of the software. It has support for using multiple configurations at once, which you can switch between in the software. We're using D3.7 now, which is great. Now you can use pan and zoom, so you can like zoom out without the browser and move things around, which is great. There's link directionality that you can use, so you can decide like a link goes one direction. There's a data generator. If you don't have any family data, you still want to play with it, you can use the sample data. There's better docs and dev experience, and I'm still working on it, but there's some auto-generated legends now. So what's next? Performance of WebGL. I want to tweak the config in the UI. But also, how can you help? You can start the repo, clone it. It's at github.com/bengarvey/lineage. Help me find bugs, contribute code. I've had a couple people contributing stuff, but really it's just, right now it's a pet project for me, but I do feel like there does seem to be a need for it because I've released it a long time ago and no one was very interested in it, but over time it's gotten some more interest. So let's take a look at it. So here it is. Looks pretty good on this. It's like a little bit of a lag on the big screen here, but we have we can see we've selected the configuration for the Haley family tree, which is my mom's maiden name is Haley. So we have Ursula Quinn here, who is my grandmother, who's kind of the center of the universe because my aunt collected this data. So she naturally starts with her own parents. Thomas Haley there. Couple of things we can hide this menu out of the way. You can kind of look at it. Like I said, we can zoom in and zoom out. We can pan around, look at different stuff, and we hover over nodes and we can get some information about them. So this is a family tree, and so you can try to find myself in here. This is my dad. You can see my mom's here, my dad's here. There's me right there. Cool. My two kids here. So one of the things, like when you look at family tree data, especially when you look at a graph like this, you can see it's settled nicely into like a nice, like the Quins here are kind of overlapping the Haleys a little bit, but if we tweak the settings, maybe we can get rid of that. But one thing, at least for me, kind of jumps out of this, that's data. Anyone see it? Looks kind of weird. Yeah. Yeah, there are some, because actually this data is actually a filtered subset of the data. So I have like a filter here where I can go through and filter for people. This is basically a filtered set of all the people I kind of know in this group, because there's lots of people I don't know in this group. And the people that are not connected probably just happen to have a last name that is similar enough to one of the other ones, and my search isn't good enough to filter it. There are also, even in the data set, there are some singletons out there. Some of them are just like people my cousins got engaged to that never actually got married that somehow ended up in the data set, which is funny. But there's one here. If you look at this loop here, like some of the branches are overlapping, but this one here in particular is like not overlapping. It's like connected. It's like this circular relationship, and there should not really be circular relationships in genealogical data, right? So this is the kind of thing you would need to know like 20 or 30 years of family lore in order to uncover. But if you look at the data, it's here. So the reason it is because there's this, my cousin Greg here for a while was married to this woman, Kathleen Vaughn, and they had a daughter, Morgan. So Kathleen Vaughn was also for a little while married to this guy, Larry Fales. Larry Fales' daughter, Holly Fales, married my brother. So we have some people in the family who are just like sort of step siblings, but also cousins a different way. And it's very confusing, but that's one of the interesting parts of the data set here. But if we really want to get crazy and remove all the filters, then it's just going to dump the entire data set in here. Kind of explodes. But luckily with our zoom, we can move out and it will just kind of settle in. Cool. We also have a night mode, so you can sort of, or dark mode, so you can sort of see it that way. It looks less good on the projector, so I'll turn that off. And one of the really cool things you can do, like I said, is you can hit this first button, zoom in, and we're back to like 1771 with two people, two McCormicks, and we're going to hit play. Hopefully this will work. And every second goes, oh, really does. All right, I'm gonna turn this off. Sorry, I can't figure out. Turn that. Oh, just gonna turn this down. All right, there we go. There's one other one that's interesting here. You see these this like relationship here between the Corcorans and the Quins. It was two brothers that married two sisters. It's right there. That's kind of cool. So I can run this again, but the it's kind of this way you can just sort of enjoy the data as it goes by, as opposed to just looking through it. Another cool thing in here, if we look at some of the Garvey side here, we have there's my father. Where's where is it? So here we have his father, my grandfather, Thomas Garvey. Then we have Thomas Garvey the second. And then we have over here, we have, this is Thomas Garvey the third. And then we have another one, Thomas Garvey the fourth. And he's here tonight. Stand up, Thomas Garvey the fourth. There he is right there. This is a data set back from 2014. So he has a son, and I'll give you a hint what his name is, and it's not Ben Garvey. I can tell you that. So that's a cool thing you can do with all this stuff. There's also, like I said, the cluster view and the timeline view. So if we switch this to a timeline view, we now see everyone arranged this way. Probably would look better with some annotations, but that's what we got, kind of minimalist view right now. We have the cluster view where everyone gets sorted by their last name, which is cool. So it looks really crazy when we take all the filters out. You can see it like that. And then the timeline view. Actually, I'm going to refresh it. Everyone, and then in the timeline view, you can really sort of see some trends here. Especially there were like sort of big gaps in new births. Anyone know what's happening in the world between the 30s and 40s? Yeah, a lot of depression, war happening, all that stuff. So the other thing was you could switch between different configurations. Like this is a one to generated data that I put in here. This was just generated from a script. So Zachary doesn't exist. Also have, I'm a big Twin Peaks fan, so I have the Twin Peaks diagram in here. This is some spoilers if anyone hasn't watched all of Twin Peaks, but this is and this is like the legend thing I was talking about, people who have like been employed by informs, kills, friends, married, all that kind of stuff, possessed. And then I was, like I said, trying to use a business use case. So I made a data set that was related to common paper, which we send contracts, right? And we close and sign contracts on our platform. So one of the things to do was trying to figure, okay, is there any network effects going on in our business? Or our customers are getting contracts that they are then turning into also common paper customers. Don't tweet this, don't blue sky this picture because this is like sensitive data, but there's no personal data, but this is company data. But if we switch to the common paper one, you can see lots of people sending contracts out. So that's going to settle in. But what we would like to see is that someone gets a common paper contract and then immediately sort of becomes a big fan of ours and starts also using the software. So the more clusters of people that are using it, the better for us. And if I use the cluster view for this, it gets really terrifying because so many people sign up with a Gmail account because it's by email address. Look at this. Really creepy in the front there. All right, that's it. Anybody have any questions? Thank you. Yeah. I do have it because I don't think in the data set I have male and female, but I have like a difference between mother and father relationships, at least in the family tree data, because that's how it came to me. I think in my generated data, I have some of that too. Yeah.
So anybody have a question? I'll run to the mic with you.
Yep.
Thank you. Yeah, my question is, if you considered for the family tree view, instead of, I guess like this like circular relationship, more of like a hierarchical tree, so you can see, I don't know, like sort of
Yeah,
like the levels of like time.
Yeah, I think yeah, that would be interesting to do if it was like that. We could sort of like the timeline view, but you still see the relationships. That'd be really cool to see. I think for where I started was like the basic layout, but also it's very space efficient. Even if anything, what I would want to do is not even use a circle, but just like try to use up and use this as available space. So if it actually couldn't cross the boundary would be kind of cool. But yeah, unique for sure.
Yeah, just a basic question about the family. What do the colors refer to?
Oh, the colors are people's last names.
Oh, okay.
So everyone who's like in the blue or a bunch of Haleys here, there's a bunch of Quinns here, but yeah, their last name. And that's one of the configurations you can do for like the Twin Peaks one. People are colored by sort of the category I gave them. So people in the FBI, people that work at the Great Northern, people at the mill, they sort of get those same things. I did a very similar chart for The Wire, but I used Semiotic, which is like Netflix's chart thing for React and D3. But I think I'll probably redo it in this soon.
Any other questions?
The Wire was more fun than Twin Peaks one to do.
Raise your hand. Yep.
Bless you.
Thanks. This was super interesting. I think the nice thing about forest-directed maps is, especially in the way that you've built it, it's beautiful. It's a piece of art. And I think the also kind of like the movie video mode is also this ability for you to see this family growing over time. I think what I'm seeing is like you've really optimized for the ability to communicate that story of like the families growing. There's more kind of like separate families coming together. Something I feel like is like a limitation of force-directed graphs, though, is it's like kind of hard to actually understand what's going on if you just
Yeah.
look at it. So I'm curious if you were to build this more of like kind of like learning information, like how would you change your approach?
Yeah, I think it comes into the interactions, right? This is the kind of thing, the feedback of like, I don't know what people would want to do with it. Like kind of the things that I would want to do with it. Right now, when you highlight over someone, you get their name. It'd be really cool to like click on them and just sort of get like how they're related to everyone in the graph. Like just sort of like maybe 2 or 3 nodes away, just like a condensed view of that person. And then you could like quickly jump back. So you could explore it, jump into details, and then jump back out to the wider context of it. Would be cool.
More questions? Excuse me.
Just to follow up on the color question,
Yeah.
I mean, it seems surprising that you would have such large groups with the same last name. Is it like kind of sort of going back in time and saying, okay, well, that's like the Haley branch of the family?
Yeah,
for
so if you
multiple
remember,
generations?
this is like a filtered view right here. So like these people are like basically all the people that I know in the group. So if we take them out, then it becomes a little bit more like spaced out. And so like, and it's like the data of the people that like the person who collected the data, they're going to start with the people that they know and start from there and then branch out. So they tend to be clustered around my aunt.
Thank you.
More questions? Yep. Cameron?
Oh, there was.
I'm curious to hear a little bit about your process in designing this. Do you go straight to code? Is there some things happening in Figma? Do you like paper? What happens before we
I
see?
definitely don't know how to use Figma at all. So yeah, no, that one, if anything, it's more just starting from paper. Like I try to keep a notebook and just write ideas from that. And if force directed graph, it kind of just looks like this always. So this was more just like code first and trying to get the examples to work back 10 years ago when everyone was on that block site that Mike made. But for all the other ones, I probably have sketches that look like the timeline view and cluster view. And my timeline sketches probably have more annotations and things like that in there that would show the years and things. But yeah, process is usually sketch something and then move on to something else. I do a lot more sketching though rather than this than for my other projects. If you go to plotdevice.bengarvey.com, those I have to all plan out ahead of time, but usually from a sketch.
Hi, this is super interesting. Because my dad is collecting our family tree information
Nice.
nowadays, so I'm like, I definitely want to play with this with my family information. But I noticed something that like the software my dad is using right now, it gives you a very hierarchical way of looking at things. And also in my family, it's like all start with the patriarch, like the grandfather, and women who are if they married out, and then like they just we lose track of the women. So like when I look at the chart you have here, it looks very democratic it's like very flat. It doesn't seem so hierarchical. I'm wondering if like for the data sets that my dad is collecting, where it's like centered around like this one patriarch,
Would it look different?
Yeah, why would it?
Yeah,
look
so I
like-
think you do get some of that because the people that are like I said, the centers of the universe are in the middle of this graph.
Yeah,
But it is like it's kind of what I like about it too, and mostly it's because of the way it's the force directed graph kind of works. Like mostly when you see in the old days of like if you're a kid in a school project, they tell you to do that with your family tree, start with your ancestors and move down from there. But
Yeah.
this sort of really just doesn't give any preference to forward or backwards. It gives preference to who has the most connections and the most like secondary connections and third connections. So that's the way it decides how to do that. But I also just like it because it kind of looks like a organism or a flower or something. So it really just like feels like life that where if you're into assembly theory, which is like this new thing of like what a definition of life is,
yeah.
it's about like that we create these sort of complex structures that just can't happen randomly in nature. And that's I feel like it's just strong evidence of that kind of thing, which is cool.
So I'm wondering, you mentioned that the colors represent different family names.
Yep. At least, yeah, in the configuration for this one, yeah, it's like that.
And so, and I'm trying to comprehend this. Maybe this is a culture difference. Like
Yes.
in the family tree my dad collects, everybody just has the same family
Mhm.
name as mine.
Yep.
So that would be just one color. How did you have so many other different colors in this cluster?
Yeah, it's funny for this one, at least the way the colors are chosen, it's just there's like a ordinal scale for D3 that gives you some good contrasting colors that look good on the page together. But like with one of what you're talking about was like different cultures, different families might have different ways of you want to categorize them. And I might want to categorize a customer data set or a TV show data set differently. This is all now, you don't have to add the code, you add the configuration. The configuration, you say, categorize them by this, and it could be one of the pieces of data, two pieces of data, and it will do it that way. Because there's all different kinds of there are cultures that have gendered last names that like they're different for
Yeah.
even though they're the same name, they're just like slightly different. So all that comes into play, and it's you can do it by configuration now, which is what I wanted to do.
Well, thank you so much for sharing this.
Yeah, thanks.
Definitely would try.
You had to have thought of putting it into 3D, right?
Like
Talk
so.
about that.
Yeah, I don't know if there's an easy way to do it in D3. If there is in the newer ones, maybe but yeah, using like 3JS or something would be kind of fun to do. Maybe when I would move to WebGL, then we'll do that one.
Thank you. I have another question. It made sense when you mentioned about approximating birth dates. I wonder how you approximate death dates.
Death dates, yeah. So there we had the one feature I didn't mention was this. I'll do the big data set, and we'll go to the timeline view. This is the sad part of the show. Where like there's a checkbox here. So this is like the one feature someone added as an open source contributor, this show dead button. If I click this, like the dead people go away, and it's like, oh, they're gone. But like when you do this, like I won't do it because it'll take a long time. But when you do the play version and see them leave the data set,
Yeah.
it's
But
what's that?
Like if the dead aren't shown there, then that's for people.
Oh yeah, I don't have death dates for everyone. I have them for some people, but not everyone. I didn't approximate the death dates.
Okay, that's what I was.
And I do in this one, the generated data. This one
Mhm.
does. You can see that it's like pretty clear that there's no missing death dates there.
Cool. My last question, just while I have the mic, if let's say you wanted to share this with someone in your family,
Yeah.
you have do you have like a shareable link, or they have to run it on localhost? Like
For my family, I had like a link that I could just send them that has like, because you notice in mine, it's like it's a first initial and a last name. That's just sort of just general privacy when I'm doing a presentation, but I have their first and last name in that version.
okay, actually, that reminds me of another question. Where are you storing the data? And like, you're storing like first name, last name, birth date, it's like sensitive information.
Yeah, it's not on GitHub. It's like a local, I have it locally.
Local
Yeah.
CSV,
Yeah.
okay.
All right, any more questions?
So in my experience, D3 Force can be like a billiard table at times. Can you describe what changes you made to keep it fairly stable here, or white
Yeah, if
screen?
you look at the in the code on the example I gave before, it's really just not this one. Oh yeah, it is this one. It's really just it's like these. Forget about the center one because it just means that we're organizing it around the center of the page. But the link charge and the alpha target are the three things that just basically dictate everything. So you just have to play with those numbers till it does something that it results in a stable thing. Like if I were to put the like a positive value for the node charge, it would just like explode the whole graph. So yeah. So it's really just trial and error, plugging numbers in, then seeing what works. And the same numbers for different graphs don't like, you have to like do it per the data set, I think.
Thank you. I have a question. Any more questions? So how do you handle the so-called hairball problem with these kinds of graphs? And are there limitations to how much data you can use with this kind of graph?
Yeah, for both of them, both questions. The first one, genealogical data is really easy to combat the hairball problem because you have basically a limited number of nodes you can have, which is the 2 parents you have and all the kids you have. So even though my grandparents who had 14 kids, that's still like a limited compared to some other types of data. Like my customer data is kind of hairbally at times. The Twin Peaks data, if you look at it again, is just a mess, right? Like there's like links everywhere. So it's trying to find any kind of structure or pattern is like a lot more difficult. So they're really, I'm still trying to figure out what that is. It's easy on genealogical data. It's not easy on other ones. There's a guy who does a whole talk on how to fight the hairball problem. You can probably find it if you search on social media to find it. But his whole thing is like most network graphs should be like scatter plots first, and then you show the network graph along with it to explain like what's going on there. But that's I forget the guy's name, but he did a great talk at Outlier one year.
So after a while, do you look at these sort of like the matrix in that you can recognize the patterns automatically? And what are some of the patterns that you have seen emerge?
So I think the biggest one, if you're trying to do a chart like this, like which is the Twin Peaks ones I'm still working on, I should show the wire one because it's kind of interesting. But really it's like how selecting the categories of all the connections. So like making sure you're limiting like ones that are important because anything you put in there is important. Like all the nodes are just the people that are there, but the categories of links are probably more important to like fixing that problem. So like even for my customer data, like I limited the only links you can have are 2 links. One is like you invited a team member to your organization or you sent someone a contract. There's a million other things we could pick that would also be relationships between customers or between users on the same app or things they did that just aren't going to give me like any kind of information that I want to look at. So just selecting good categories for links.
Any other questions?
This isn't a question, but I just wanted to say that I saved my most important announcement till last, and that is to thank Cameron and Datadog for hosting us. Let's hear it for Datadog, for the pizza, for the refreshments. And it's not just tonight, it's for years. They have been hosting us online, in person. We cannot thank them enough. So I will give it back.
Right. Yeah, and thank you all. And once again, just think about coming to our meetup on March 12th in Philadelphia. It's at 4th and Market at Cesium. And one of the organizers of this meetup will be giving a talk. Naomi's going to come down to Philadelphia in March. So thanks.
Yeah, so thanks for coming out tonight. We still have the space for till 8:15 actually, so feel free to hang out. We have another speaker coming in May for sure, and Batul wanted to make it, but she couldn't make it tonight. She organized the DVS Society, but we're in talks to maybe do something before then. So keep your eyes out. Oh, yes.
All right, yeah. So we're here till 8:15. If anyone, I'm going to be here tonight. If anyone wants to hang out, I'm going to Theory Lounge after this, which is right around the corner. So